Hello everyone, this is Dr. Krishna Kumar, working as Assistant Professor in the Department of Civil Engineering, SRM Madurai College for Engineering and Technology. This is a group of SRM group of institution. So today's topics is on beams and its classification. So the prerequisite for this course is uh, this is just a general engineering information about civil engineering. So there is no prerequisite. If you are able to understand some basic physics, that is enough to listen to this lecture. The books, the books I have referred for this particular course is Strength of Materials by Chand Publication. R. Rajput is the author, and Bansal as well as Bhavikati. So some other books and net resources are being used for this particular presentation. So first question what is arrived in my mind is, so you might have seen a building. So have you ever located a beam in the building? So which part of the building we call it as a beam and what it does? That is the first content of this course. So if I ask a common man what is a beam, so he may tell that a horizontal member in a building may be called as beam. So this structure what you see in the screen is a beam. So it is acting, it is being located in a horizontal way. Fine. So if you see a structure, so like this, so this horizontal element is called as a beam. So what is the vertical element being called? So the vertical element is called as column. So both have different functions. So the beam will be acting as a load transmitter by undergoing flexure, whereas a column will also do the same process by undergoing compression. So both has two different roles to play in a building. So beam will take load and bend, will undergo bending. So once you apply a load on it, it will be bending. And if you apply a load on column, it will undergo compression. It will be extremely compression member. And one more classification is the beam will take the load perpendicular to its longitudinal axis. So you can see the length of the beam. So always the load will be acting perpendicular to it, which means in a 90-degree to the beam. And whereas in case of column, the load will be acting parallel to its longitudinal axis. Okay, fine. So what do we want a beam? Why do we want a beam in our house? So what is the function? What it does actually? Why do we need that? What if it is we don't have a beam in a house? So the main purpose of the beam in a house is to transmit the load. So you can see the picture here. So there is a slab. So this slab, if you stand on the slab, so your load has to be safely transmitted to the earth, right? So for that, this slab will transmit the load to the beam, and the beam will give it to the column, and column will give it to the foundation, and the foundation will give it to the subgrade, that is soil. So this is how the load transfer should be taking place, but these load transfers should be taking place in a safe condition without any failure or crack in the structure. That is very important. So the beam should be adequate enough to carry the load and transmit it to the column. So that is the main function of the beam. So that is why we want a beam in our house. So if you don't have a beam, of course the beam will the load transfer mechanism will be a failure. So your structure may have lesser lifespan. So beam is a primary important element in your house. So here comes the question, how many types of beams you have in our house? So of course, so if you take a cross section of a house, so this is the answer for it. So I can say that there is a plinth beam, a tie beam, as well as a slab beam. So slab beam is nothing but a beam that is beneath the surface of the slab. So this carries the load from the slab to the column, and the tie beam is called as lintel beam. So this will be above the windows openings or any door openings. This is a tie beam. This will usually connect two columns, as well as a plinth beam. This will be under your ground level, that is your floor level. So below your floor you'll have this beam. So this, most of you might have known this. If you want to construct your own home, you must take care of these three beams, whether it is available or not. So first one is the slab beam, I repeat, a tie beam, as well as a plinth beam. The plinth beam is most important, as tie beam is required for constructing any openings, and the slab beam is required for transferring the loads from the slab to the column. So I'm going for classifications of beams based on its support conditions. So you can see there are 5 supports: simply supported beam, continuous beams, overhanging beams, cantilever beams, fixed beams. So of course, these, based on the support condition, you can classify these types of beams. I can give you some real-time examples also. So anything that is fixed on both sides, if you take your own house, the beam in your house is completely fixed. And cantilever, your sunshade will be a cantilever. And continuous beams, you might have seen this metro rail bridges, that is a continuous beam example for continuous beams. And classification based on construction materials we are using. So of course, you know that RCC, reinforced concrete beams, completely made up of concrete and steel. And the next one is steel beams. You might have seen across this railway bridges. So the picture what you see here is steel beam. And of course, timber beam. Some pedestrian bridges, you might have seen this in some hill stations, some resort stations. You have this timber beams will be available, and composite beams, this is available across a railway crossing. So based on materials we use for constructing a beam, these classifications being made. And classification by the shape, cross-sectional shape, you have a basic a concrete beam will have 3 classifications: rectangular, T-beam, and L section beam. So the images are available. And if you have a steel, with steel we can make many different shapes. So these 4 are most used steel sectional beams. There is a circular hollow, a I-beam, and wide flange beam, as well as rectangular tube beam. You might have seen all these things in your home applications, as well as some truss roof structures. And classification based on geometry. So based on the shape of the beam, that is the top view of the beam. So you can see this, there is a straight beam. Straight beam, of course, you might have seen ordinary beam that is available in your house will be a straight beam. And curved beams, see the picture is showing that there is a water tank. The beam below the surface of the slab of the water tank is the curved beam. And tapered beam, so the cantilever, the portion you see in this right side image, the column appear having a top beam above it is a tapered beam. The size is reducing over its length. Classifications by method of construction. So cast in situ, precast concrete beam, pre-stressed concrete beam. So cast in situ is nothing but the beams casted on the site. As you know, majority of the beams are cast in situ. And precast concrete beams is the latest technology. What it does is, if you prepare the concrete beam in your factory, apart from the site, and you take it, transport it to the site and fabricate it. So this is a precast concrete beam. And pre-stressed concrete beam, this is a huge big topic where you can Google it. Of course, this I'll give you a small glimpse of this topic. Pre-stressed concrete beam is your railway sleepers you see in the railway track is the pre-stressed concrete beam. And there is a question for you. I don't find beams in some theaters and shopping mall. Why is it? So this is the gateway for the next topic, that is flat slab. So we call it as flat slab, where we don't have beams in between. So if you go for a theater or a shopping mall, you might not seen this beams in between. So where is the beam there? How the load transfer is occurring? So for that, you should refer the topic on flat slabs. So we'll see about in the next lecture. Thank you.